Good morning. So your first remote learning assignment was to review all the factoring techniques you learned earlier in the school year. Recently, we studied different types of functions, and one of those types of functions that we studied was the rational function. Today, we will connect these two ideas. Factoring polynomials will help us simplify rational expressions. Soon, we will perform operations on rational expressions. So we'll add, subtract, multiply, and divide. But before we're able to do that, we need to make sure that we're able to simplify those types of expressions. So as a review, a rational expression is an expression of the form h of x over g of x, where h and g are both polynomial functions, and g of x cannot equal 0. A rational expression is in simplified form if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, we're going to apply the following property. So if you take a look, basically what we're going to do is we're going to divide out any common factors that appear in the numerator and denominator. So in certain cases, it's going to be clear what the common factors are. In others, what we're going to have to do is apply the factoring techniques that we learned earlier on in the year, as I had mentioned before, to simplify, again, these expressions. Let's take a look at an example. So we're asked to simplify the expression 40x plus 20 over 10x plus 30. So the first thing that we're going to look for are greatest common factors in the polynomials in the numerator and the denominator. So if we look at the numerator, we see that 40x and positive 20 have a greatest common factor of 20. So I'm going to factor that out. 40x divided by 20 is 2x. And then 20 divided by 20 is 1. If we look at the bottom of the denominator, the greatest common factor for those terms is 10, so we're going to factor out a 10. 10x divided by 10 is just x, and then 30 divided by 10 is 3. Now what we'll do is we'll check and see if the remaining polynomials can be factored any further. 2x plus 1 is a linear binomial, so that's not going to be factorable any further. And then x plus 3 is also a linear binomial, so we're not going to be able to factor that any further. So we're just going to divide out any common factors that appear in the numerator and denominator. So 20 divided by 10 is just 2. So that's going to leave us with 2 times the quantity 2x plus 1 over x plus 3. And this will be our final solution for this example. Let's take a look at a second example. This time we're asked to simplify x squared minus 2x minus 15 over x squared minus 9. X squared minus 2x minus 15, those terms contain no common factors. The same thing with x squared minus 9. So what we're going to do is try to factor those using the techniques that we learned earlier on this year and that we just reviewed. So x squared minus 2x minus 15, that can be factored down to x minus 5 times x plus 3. X squared minus 9 is a difference of two squares, so that pattern is x minus 3 times x plus 3. So as we did in the previous example, we're going to check for common factors in the numerator and the denominator. And it's clear that x plus 3 is a common factor in the numerator and denominator, so we're going to cross those out because those divide out to equal 1, and that's going to leave us with x minus 5 over x minus 3 as our final answer. We'll get one more example. We're asked to simplify 3x cubed plus 6x squared plus 12x over x cubed minus 8. So again, I'm going to take a look at the numerator first, and I'm going to see if there are any common factors in the numerator. And it appears that we can factor out a 3x from all of those terms, so I'm going to do that. 3x cubed divided by 3x is x squared. 6x squared divided by 3x is 2x. And then 12x divided by 3x is positive 4. I'm going to take a look at the denominator, see if there are any common factors in the terms in the denominator. We have x cubed minus 8. I'm going to leave that alone for now. That's actually a difference of 2 cubes, so we're going to factor that as a difference of 2 cubes in a second. So now I'm going to check the numerator. X squared plus 2x plus 4. 4x squared is what we get if we multiply the constant term and the first term together. And we're looking for factors of 4x squared that add up to 2x. We're not going to be able to find those because the only factors would be 4x and x, or negative 4x and 1x, and then 2x and 2x, or negative 2x and 2x. And none of those options add up to 2x. So x squared plus 2x plus 4 is not going to factor any further. So let's try and factor the denominator and see what we come up with. So we're going to do 3x squared plus 2x plus 4. Now the difference of cubes pattern is going to give us x minus 2 times x squared plus 2x plus 4. And what you'll see is that now we have a common factor in the numerator and denominator of x squared plus 2x plus 4. So those will divide out. And we are going to be left with 3x over x minus 2. I hope this video was helpful. I'm also going to be posting these notes to Google Classroom, as you will see in the little schedule that I've been posting. If you have any questions, feel free to email me. I hope everybody's feeling good. I hope everybody's doing well, and hope to see all you guys soon. Have a great day.